The reason 12 volts alternating current lighting is placed further away from a pool is because it requires a transformer to convert the standard 120 volts alternating current power supply to 12 volts alternating current. The transformer can present a safety hazard, as it can create a ground fault if it becomes submerged. Therefore, 12 volts alternating current lighting is kept 10 feet away from the pool to minimize the risk of electrical shock. Now let's consider 12 volts direct current solar lighting. 12 volts direct current solar lighting does not require a transformer. It relies on a battery to store the energy generated from the solar panel. Therefore, there are fewer ground fault risks associated with 12 volts direct current solar lighting. However, it's still important to consider several factors when placing 12 volts direct current solar lighting around a swimming pool. Firstly, you must consider the electrical code. Local electrical codes may still specify a minimum distance for lighting around pools, regardless of the voltage. It is important to check with your local authorities for specific regulations. Secondly, minimize glare. Place lighting fixtures in a way that minimizes glare into the pool or surrounding areas. Thirdly, consider durability. Choose lighting fixtures that are rated for outdoor use and can withstand moisture and harsh weather conditions. Fourthly, consider safety. Ensure that all wiring and connections are waterproof and secure to prevent any potential electrical hazards. While 12 volts direct current solar lighting typically has less stringent safety requirements than 12 volts alternating current lighting, it is still advisable to consult with a qualified electrician or refer to the local electrical code for specific guidance in the placement of lighting around swimming pools. Now let's go into some more detail. When installing electrical equipment near a swimming pool, hot tub, or spa, safety is paramount. The National Electrical Code, or NEC, provides specific guidelines to minimize the risk of electrical shock. Understanding these requirements is crucial for ensuring a safe environment for swimmers and anyone using the pool area. These codes address various aspects of electrical installations, including wiring methods, grounding, bonding, and the placement of electrical equipment. Following these regulations helps to prevent electrical hazards and maintain a safe aquatic environment. Firstly, let's discuss bonding. Bonding is a process of connecting all metallic parts of the pool structure and equipment to create an electrically continuous path. This includes the pool reinforcing steel, metal fittings, pump housings, and any other metallic components within a certain distance of the pool. The purpose of bonding is to equalize the electrical potential between these parts, reducing the risk of electrical shock if a fault occurs. According to NEC Article 680.26, all metallic parts must be bonded together using a solid copper conductor no smaller than number 8 American wire gauge, or AUG. This conductor must be connected to a common bonding grid. The bonding grid serves as the central point for all bonding connections, ensuring that all metallic parts are at the same electrical potential. This significantly reduces the risk of dangerous voltage differences that could lead to electric shock. Next, let's review grounding. Grounding provides a path for fault current to return to the electrical source, tripping a circuit breaker or ground fault circuit interrupter, or GFCI, and cutting off power to the circuit. This helps to prevent electrical shock and equipment damage. NEC Article 680.21 specifies the grounding requirements for pool equipment. All electrical equipment associated with the pool, such as pumps, filters, and heaters, must be grounded to the equipment grounding conductor of the branch circuit. This conductor must be sized according to NEC Table 250.122, based on the rating of the overcurrent protective device in the circuit. In addition to equipment grounding, the NEC requires the installation of a ground fault circuit interrupter, or GFCI, protection for most electrical circuits near the pool. A GFCI is a device that monitors the current flowing in a circuit and quickly interrupts the power if it detects a difference between the outgoing and return currents. This difference indicates a leakage of current, which could be a sign of an electrical fault or shock hazard. NEC Section 680.22 requires GFCI protection for all 120 volts through 240 volts receptacles within 20 feet of the inside walls of the pool. This includes receptacles for pool equipment, as well as general-purpose receptacles that may be used by pool users. GFCI protection is also required for lighting fixtures and other electrical equipment installed within the same area. Moving on to wiring methods. The wiring methods used for electrical circuits near the pool must be suitable for wet locations and resistant to corrosion. NEC Article 680.14 specifies the requirements for wiring methods. Underground wiring must be installed in rigid metal conduit, intermediate metal conduit, or rigid non-metallic conduit. Direct burial cables are not permitted. The conduit must be buried at least 6 inches below the ground surface and must be properly supported and protected from physical damage. Wiring above ground must be installed in rigid metal conduit, intermediate metal conduit, electrical metallic tubing, or other approved raceways. The wiring must be securely fastened to the support structure and must be protected from physical damage. Now let's talk about equipotential bonding. Equipotential bonding is a more comprehensive form of bonding that aims to eliminate voltage gradients in the pool area. Voltage gradients occur when there are differences in electrical potential between different points on the ground or in the water. These voltage gradients can create a shock hazard for swimmers. NEC Section 680.26 requires equipotential bonding for all metal parts within the pool area, including the pool reinforcing steel, metal fittings, pump housings, and any other metallic components. The bonding conductor must be connected to a common bonding grid, which is then connected to the equipment grounding conductor of the electrical system. In addition to bonding metal parts, equipotential bonding may also be required for the pool water itself. This is typically achieved by installing a metal plate or grid in a pool and connecting it to the bonding grid. The purpose of bonding the water is to equalize the electrical potential between the water and the surrounding surfaces, reducing the risk of electrical shock for swimmers. Let's review clearances. Maintaining proper clearances around electrical equipment is essential for safety and accessibility. NEC Section 110.26 specifies the working space requirements for electrical equipment. There must be sufficient space around electrical equipment to allow for safe operation and maintenance. The working space must be clear of obstructions and must provide adequate headroom. In addition to working space, there are also clearance requirements for the placement of electrical equipment near the pool. NEC Section 680.22 specifies the minimum distances that electrical equipment must be located from the inside walls of the pool. These distances vary depending on the type of equipment and the voltage of the circuit. For example, receptacles must be located at least 10 feet from the inside walls of the pool, while lighting fixtures must be located at least 12 feet from the water's edge. The requirements we just covered apply to both permanent and temporary pools. A permanent pool is defined as a pool that is intended to be installed for more than 180 days. A temporary pool is defined as a pool that is intended to be installed for a period of 180 days or less. The NEC provides additional requirements for temporary pools to ensure that they are installed safely. These requirements include the use of ground fault circuit interrupter, or GFCI, protection for all electrical circuits, as well as the proper grounding and bonding of all metallic parts. It is important to note that the NEC is a minimum standard and that local codes may have additional requirements. It is always a good idea to check with your local building department or a qualified electrician to ensure that your pool installation meets all applicable codes. Here are some additional safety tips for electrical equipment around swimming pools. Firstly, never use electrical appliances near the pool. Keep radios, televisions, and other electrical appliances away from the pool area. These appliances can pose a serious shock hazard if they come into contact with water. Secondly, inspect electrical cords and equipment regularly. Check for frayed cords, cracked housings, and other signs of damage. Replace any damaged equipment immediately. Thirdly, use ground fault circuit interrupter, or GFCI, protected outlets. Make sure that all outlets near the pool are protected by ground fault circuit interrupters, or GFCIs. Test the ground fault circuit interrupters, or GFCIs, regularly to ensure that they are working properly. Fourthly, turn off power before working on electrical equipment. Always turn off the power at the circuit breaker before working on any electrical equipment near the pole. This will help to prevent electrical shock. Fifthly, hire a qualified electrician. If you are not comfortable working with electrical equipment, hire a qualified electrician to do the work for you. A qualified electrician will have the knowledge and experience to install and maintain electrical equipment safely. Sixthly, keep electrical equipment dry. Keep electrical equipment dry to prevent electrical shock. Do not allow electrical equipment to come into contact with water. Seventhly, be aware of the dangers of electricity. Electricity can be dangerous, so it is important to be aware of the risks. Follow all safety precautions to prevent electrical shock. Let's switch to the specifics of 12 volts direct current solar lighting systems. 12 volts direct current solar lighting systems offer a safer alternative to traditional 120 volts alternating current lighting, especially in areas near water sources like swimming pools. The lower voltage significantly reduces the risk of electric shock, making it a popular choice for outdoor lighting. However, it's essential to understand the components and proper installation techniques to ensure both safety and optimal performance. 12 volts direct current solar lighting systems typically consist of a solar panel, a charge controller, a battery, and the lights themselves. The solar panel converts sunlight into electricity, which is then regulated by the charge controller to prevent overcharging the battery. The battery stores the energy for use when sunlight is not available, and the lights draw power from the battery to provide illumination. The design of these systems inherently reduces electrical hazards. The low voltage minimizes the potential for dangerous current flow through the body in the event of a fault. Additionally, because the system is often isolated from the main electrical grid, there is less risk of ground faults causing shocks. The solar panel should be positioned to maximize sunlight exposure throughout the day. A south-facing orientation is generally optimal, but adjustments may be necessary depending on local conditions and shading from trees or buildings. The angle of the panel should also be adjusted seasonally to capture the most sunlight. The charge controller is a critical component that regulates the flow of electricity from the solar panel to the battery. It prevents overcharging, which can damage the battery and reduce its lifespan. Charge controllers also protect against reverse current flow from the battery to the solar panel at night. Batteries used in 12 volts direct current solar lighting systems are typically deep cycle batteries designed to withstand repeated charging and discharging. These batteries are available in various types, including lead acid, absorbent glass mat, or AGM, and lithium-ion. Lithium-ion batteries offer higher energy density and longer lifespans but are more expensive. The choice of battery depends on the specific requirements of the lighting system and the budget. The lights themselves can be light-emitting diodes or LEDs, incandescent bulbs, or other types of low-voltage lighting. Light-emitting diodes or LEDs are the most energy-efficient option and offer long lifespans, making them a popular choice for solar lighting systems. The wiring used in 12 volts direct current solar lighting systems must be appropriately sized to handle the current and voltage. Undersized wiring can cause voltage drops and reduce the performance of the lights. It's also important to use wiring that is rated for outdoor use and is resistant to moisture and ultraviolet, or UV, radiation. Connections should be made using waterproof connectors to prevent corrosion and ensure reliable operation. Grounding is an important safety consideration for 12 volts direct current solar lighting systems. Although the risk of electric shock is lower than with 120 volts alternating current systems, grounding can still help to protect against lightning strikes and other electrical disturbances. The solar panel frame and any metal enclosure should be grounded to a grounding electrode, such as a ground rod. Regular maintenance is essential for ensuring the long-term performance and safety of 12 volts direct current solar lighting systems. The solar panel should be cleaned periodically to remove dirt and debris that can reduce its efficiency. The batteries should be checked regularly for signs of damage or corrosion. Connections should be inspected to ensure that they are tight and free of corrosion. Let's review the National Electrical Code, or NEC, requirements. While 12 volts direct current solar lighting systems are generally considered safer than 120 volt alternating current systems, it's important to be aware of any applicable National Electrical Code or NEC requirements. The NEC provides guidelines for the installation of solar photovoltaic or PV systems, including requirements for wiring, grounding, and overcurrent protection. Although 12 volts direct current solar lighting systems may not be subject to all of the same requirements as larger solar power systems, it's still important to follow good electrical practices and consult with a qualified electrician if you have any questions. Furthermore, it is imperative to consult local codes and regulations regarding the installation of electrical equipment near swimming pools. These codes may specify minimum distances, wiring methods, and other requirements that must be followed to ensure safety. In some cases, a permit may be required for the installation of 12 volts direct current solar lighting systems near a pool. Also, ensure that all electrical components used in the lighting system are rated for outdoor use and are resistant to moisture and corrosion. This includes the solar panel, charge controller, battery, lights, and wiring. Using appropriately rated equipment will help to ensure the long-term reliability and safety of the system. Ensure that all wiring connections are made properly and are protected from moisture and corrosion. Use waterproof connectors and sealants to prevent water from entering the connections. This will help to prevent short circuits and other electrical problems. Here is a summary of some critical safety considerations to remember. While 12 volts direct current solar lighting systems offer a safer alternative to traditional 120 volts alternating current lighting, it's still important to take precautions to prevent electrical shock. Avoid touching any exposed wiring or connections, and always turn off the power before working on the system. Keep the solar panel and other electrical components clean and dry to prevent corrosion and ensure optimal performance. Clean the panel regularly to remove dirt, dust, and debris. The battery should be checked periodically for signs of damage or corrosion. Replace the battery if it shows any signs of deterioration. Visually inspect the wiring and connections regularly to ensure that they are in good condition. Repair or replace any damaged wiring or connectors. If you are not comfortable working with electrical equipment, hire a qualified electrician to install and maintain the 12 volts direct current solar lighting system. A qualified electrician will have the knowledge and experience to ensure that the system is installed safely and correctly. By following these safety precautions and best practices, you can enjoy the benefits of 12 volts direct current solar lighting around your swimming pool while minimizing the risk of electrical shock and other hazards. Finally, you should understand lighting placement and potential glare. The positioning of lights is crucial for both aesthetics and safety. Poorly placed lights can create glare, reduce visibility, and even pose a hazard to swimmers. It's important to carefully consider the angle, intensity, and color of the lights to achieve the desired effect without compromising safety. Light should be positioned to illuminate the pool area without shining directly into the eyes of swimmers. This can be achieved by using shielded fixtures, recessed lighting, or by angling the lights away from the pool. The intensity of the light should be sufficient to provide adequate illumination without being too bright or overpowering. The color of the lights can also affect visibility and the overall ambience of the pool area. Warm white lights are generally preferred for creating a relaxing and inviting atmosphere, while cooler white lights can provide better visibility for swimming and other activities. Remember to consult with a qualified lighting designer or electrician to determine the best lighting placement for your specific pool and surrounding area. They can help you to choose the right fixtures, angles, and intensities to achieve the desired effect while ensuring safety and compliance with local codes.